Hey everybody, this is Unit 4, Lesson 2. Today we'll be talking about rotations and what's called rotational symmetry. Now what our main focus will be on today is something that's called a turn. Now a turn is something we do when we rotate a figure a certain amount of degrees and we decide if we're going to go clockwise, which is with the hands of the clocks, or something that's called counterclockwise, which would be the opposite way that the hands of a clock move. The first term you'll need to remember is something called a quarter turn. Now a quarter turn is a certain type of rotation in which we rotate 90 degrees, either clockwise or counterclockwise. So each of these circles show a different quarter turn. The first one shows the clockwise version. The second version shows counterclockwise. Now, using this Bitmoji, I'm going to show you what both of those turns would look like. So if I take the original figure, which is standing right up, and I go 90 degrees clockwise, so moving the figure with the clock 90 degrees. Now that we've done a 90 degrees clockwise rotation, you can see that the figure is facing a different direction. If I go back to the original shape, so standing right side up, and this time I do 90 degrees counterclockwise, you'll see that it looks a little bit different. Now the character is facing to the left. So 90 degrees is just a quarter turn. Down below here we have another example of a turn, and this one's called a half turn. It looks like we're taking up half of the circle. Just like with a quarter turn, we were taking up a quarter or 1/4 of the circle. Now, a half turn is equivalent to 180 degrees. So the first figure here shows a 180 degree turn clockwise. The second figure shows a 180 degree turn counterclockwise. I'll show you that again, but with this Bitmoji down below. So remember that a half turn takes up half the circle. So I'm going to be rotating the character 180 degrees this time instead of just 90 degrees. So I'll get started by taking the Bitmoji and we're going to do clockwise first. So it's standing right up for now. A 90 degree turn would be stopping here where it's facing the right. 180 degrees would be turning it again, so now the character is facing upside down. Now that was 180 degrees rotating it clockwise. Now I'll face the character back up so that you can see a 180 degree counterclockwise half turn. So this time I would first rotate 90 degrees to the left here, and then for a full 180 degrees or half turn, it would now be facing upside down again. We just went the other direction to do counterclockwise. Now I have a couple more turns to show you. The next one is something called a 3/4 turn, which is 270 degrees. A 3/4 turn, you'll notice, takes up 3/4 of the circle or 3/4 of the circle. So the first figure here shows clockwise, rotating 270 degrees. The second figure again shows 270 degrees turn counterclockwise. So first I'll show you the first one, clockwise, with my figure. So as it is standing right side up, it's the original figure. Start rotating it clockwise 270 degrees. So here's 90, 180, 270 degrees clockwise turn. Now let's go back to the original figure, and this time I'll show you 270 degrees counterclockwise. So this time I'll go to the left first. There's 90, 180, 270 degrees counterclockwise. The last turn is something that we call a full turn. That's where we rotate around the whole circle, so it's 360 degrees. It's a full turn because a circle does have a full 360 degrees inside of it. So that's why we call a full turn 360 degrees. The first figure shows us 360 degrees turn clockwise, going with the hands of a clock. And the second one shows us 360 degrees or a full turn going counterclockwise. So I'll show you that with this figure. First we'll go clockwise. We'll start by going 90 degrees, 180 degrees, 270 degrees, 360 degrees. A full turn will bring my figure back to its original facing point. So this case, standing straight up. Now, if I do that counterclockwise, we'll still do 360 degrees, so a full turn just going the other direction. So first we'll do 90 degrees this way, 90, 180, 270, 360. So again, she's facing standing up again, but we went left counterclockwise for a full 360 degree turn. Now we'll take a look at these different types of rotations with different figures than the Bitmoji character. So the key thing to remember is that a rotation is a turn. You're turning the figure a number of degrees and a certain direction, either clockwise or counterclockwise. Remember, clockwise is with the hands of the clock, counterclockwise is the opposite of the hands of a clock. So in number 1, they need us to circle the answer choice that shows the pencil after a 90 degrees counterclockwise turn. So 90 degrees would just be one rotation, and counterclockwise would be against the clock. So here, as you can see, I have the pencil as what it would look like as its original shape, which it shows us there up top. And 90 degrees would be going just one rotation. Counterclockwise would look like this. So 90 degrees counterclockwise. So the choice we would want here is letter C. Shows the figure after a 90 degrees counterclockwise turn. Number 2 has a right triangle. We need to circle the answer choice that shows the figure after a 270 degrees clockwise turn. So 270 is 3 rotations, and we want to go clockwise, so with the clock. So again, I've created this right triangle to show you the actual rotation. So here is its original shape. First we'll go counterclockwise, or no, I only need to remember clockwise. So 90 degrees, 180, 270. Okay, so now the right angle's on the bottom. So the choice that I would like is choice B. Quick tip for you 4th graders, you won't always have a cutout of the original figure like I did here. So something that I recommend doing is, if you're not quite sure, take your paper and turn it the amount of times you need to, like 270 degrees or 90 degrees. And after you've turned your paper the correct amount of degrees, turns, and the correct direction, you'll be able to see what the shape would look like after you've done the correct turn. Now we come to our last term, something that's called rotational symmetry. A figure has rotational symmetry if you can turn it about its center and it fits exactly on itself in less than one full turn. Which, remember, a full turn is 360 degrees. So basically a full turn is bringing it right back to its start anyway. So all figures have full turn symmetry because you're bringing them right back to how they looked anyway. A square is a figure that has a lot of different rotational symmetry. So if I rotate this square here 90 degrees, you'll see that it still looks exactly the same. There's the original. Looks exactly the same, didn't change. So 90 degrees, still looks like a square. 180 degrees, again, still a square. And 270 degrees, exactly the same. So if I flip it back and do a full turn, 360 degrees, you can see it still looks the same. Nothing has changed here. So square, yes, does have rotational symmetry at 90 degrees, 180 degrees, and at 270 degrees, and then the obvious one, 360 degrees. But we're going to take a look at 2 other figures, a rectangle and a pentagon. We need to decide, does each figure have rotational symmetry? Write yes or no. If a figure has rotational symmetry, write the number of degrees of the rotation. So we'll try this first with the rectangle. Get it ready here. So the first thing I want to do is go 90 degrees. And no, it does not look the same. It's no longer sideways, it's up and down. So far, no rotational symmetry. But what happens when I do a 180 80 degrees. Okay, so now I've gone 180 from the original. Here, I'll show you that again. So here's the original, 90, 180. Okay, so far, yes, we do have rotational symmetry. We have it at 180 degrees. Let's see if we can find any more. Now, this would be a 270. Okay, so 270 degrees. Again, it's up and down instead of side to side, because if I do and finish the full turn here, now it's at 360 degrees. So the only time I had rotational symmetry was at 180, that half turn. Then it looks the same. Okay, so now let's go on to my pentagon over here. Let's see about this one. So up and down with the point facing up, we need it to look the same with a point facing up for it to have rotational symmetry. All right, here's 90 degrees. Definitely not the same. Now it looks like a house on its side. Okay, let's try. So from the original, 90, 180. Okay, now the house is upside down, so it doesn't look the same at all. All right, so let's go back to the original. Let's try again. So 90, 180, 270. Now the house is facing the right side. So this figure, unless I bring it back 360 degrees, which remember all figures have 360 degrees because you just bring it right back to the original. So this figure is a no. There's no rotational symmetry. It doesn't look the same unless you bring it back to its original standing point. So no 90, no 180, and no 270 degree symmetry here. All right, ladies and gents, on your ticket today, you have a couple of jobs. The first one is to decide if these two figures, this heart and this hexagon, have rotational symmetry. Write yes or no first, and then if a figure has rotational symmetry, so if you write yes, tell me the number of degrees of the rotation where it looks the same. So that's just like what I did on the previous slide. Then number 3 on your ticket today says circle the answer choice that shows the figure after a 90-degree clockwise turn. So 90 degrees would just be one turn clockwise following the clock. And then number 4, circle the answer choice that shows the figure after a 360 degrees turn. Good luck, 4th graders. I know you will be awesome.